welcome back. And the spatial filtering is an image sharpening we told you before, like in the previous video. Working on a neighborhood of every pixel and the neighborhood processing is called as a sharpening or spatial filtering. The thresholding is nothing but piecewise linear transformation which produce a two-level binary image for any 0 which is less than equal to t or less than 255. The threshold transformation can be defined as s is equal to 0 to r. Otherwise, the thresholding is in another form of, here the thresholding transformation are particular useful for segmentation in which we want to isolate an object of interest from the background images. This thresholding transformation is input gray level R and output gray level S here. Image enhancement, that is spatial and frequency enhancement. The spatial domain is like image enhancement. Three basic level of functions are used to image enhancement. Image enhancement point processing techniques. Linear is a negative image and identity transformations, logarithmic transformations, power law transformation, nth power and nth root transformation, gray level slicing, bit plan slicing, everything. We are dealing now with image processing methods that are based only on the intensity of single pixels. The intensity transformations are the gray level transformation, the linear function negative and identity transformations, the logarithmic function or log and inverse log transformation, power law function, nth power and nth root transformation. Here we consider that the digital image that are considering that will have capital L number of intensity level represented from 0 to capital L minus 1 in steps of 1. The negative of the digital image is obtained by the transformation functions s is equal to t of r, L minus 1 and minus r here. The logarithmic function is the general form of the log transformation is s is equal to c into log 1 plus r. C is a constant and r is assumed to be greater than or equal to 0. The log transformation maps a narrow range of low input gray level values into a wide range of input values. The inverse log transformation performs the opposite transformation s is equal to log 1 plus r. We usually set c plus 1. The gray levels must be in the range of 0, 0.1, 1.0. The identity function is output intensities are identical to input intensity is included in the graph only for completeness. The power law transformation. Why power laws are very popular here? A cathode ray oscilloscope, that is CRT for example, which has been converted your video signal to a light in such a way that the light intensity is proportional to the power y of a source voltage Vs for a computer CRT. Y is about 2.2. So coming back to this point, the identity function and the logarithmic functions are the negative of that particular digital image is obtained by the transformation function. Here from iris recognition to retina or corneal recognition, this s is equal to 1 minus 0 minus r, that is from the s is equal to t of r is equal to L minus 1 minus r here. And throughout the session we have seen the n pixel point, that is the neighboring pixels, how it is being sharpening the images. The distance d between the 2 points is defined as the shortest m path between these points. These are called as the neighboring points. The distance between the 2 pixels will depend upon the value of the pixel along the path as well as the values of their neighbors of that particular pixel. Say for example, we have 3 by 3 images, that is we are just considering f of x comma y, that is coordinates in spatial domain and all. We will be considering that function x comma y as the coordinates of that particular image. Here we are just considering the following arrangement of pixel and assuming that p comma p2 and p4 have the value of 1. P2 and P4 have the value of 1 and P1 and P3 can have a value of 0 here. So the connectivity of that particular pixel's value 1 is allowed and P1 and P3 are a 0, then the m distance between P and P4 is 2. If either P1 or P3 is is 1, the distance is 3. If both PI and P2 are 1, the distance is 4. So this session's assessment questions are the spatial domain techniques, gray level in transformations in image processing, low pass filters, median filters, how it has been worked, and bit plan slicing works. Thank you.